Hi everybody, I'm Professor Rad, and today we're going to talk about 3 different types of random sampling techniques. So in the last video, we left off with a systematic sample, and I talked a little bit about that not being random, but now let's talk more specifically about what we mean when we say random in a statistics class. So our first type of random sample is going to be called a simple random sample. And because the sampling type is used a lot, and because mathematicians don't like to write a lot of stuff, we're going to abbreviate this with SRS. So SRS for simple random sample. So you'll frequently hear things like an SRS of 16 people is selected. So that's why I have here this size n. N is going to be like however many people we look at total. So if I look at 1,000 people from my simple random sample, then I would say that I took an SRS of size n, of size 1,000, right? Or n would be 1,000. And when you select this sample, every member of that population is equally likely to be selected. So in a systematic sample, the last one we looked at, we saw that it was not random because not everything is as equally likely to be selected. Whereas in a simple random sample, everybody has an equal chance, kind of like a lottery. Okay, so that's that note at the bottom. You can think of an SRS like a lottery. Usually the way that you select a simple random sample is you assign every person or thing in your population, you give them all a number, and then you use some kind of random number generator. This could be something on the computer. Usually some calculators can find random numbers for you, and you use that to select your sample. And we'll do an example of that in a little bit. So in this example here, though, let's see why we can identify this as an SRS. So it says the paint company obtains a list of all residential addresses in San Diego and Boston. Using a computer, they randomly select a list of 200 addresses in each city and determine the color of those houses. So using a computer, they randomly select. So here's our simple random sample. They're just selecting members from their population. So let's do a little randomness experiment. All right, so in this randomness experiment, it says suppose Mandy, Nina, and Othello are asked to create a list of 5 random numbers from 1 to 3. And then here are the lists that each person created. So Mandy has 1, 2, 3, 2, 1. Nina has 3, 3, 3, 3, 3, and Othello has 3, 1, 2, 2, 1. So take a moment to answer these 2 questions. Whose list of numbers is the most random, and whose list of numbers is the least random? What do you think? So this is kind of misleading questions. So when you have a random sample, every number is equally likely to be selected. So if we're picking random numbers from 1 through 3, in each of these situations, I have a 1/3 chance of picking each number. So each of these lists could totally be random. Now, if you were thinking though, like Nina's list is really not very random because she got 3, all 5 times. Her list is not very likely, but that doesn't mean it couldn't be random. Similarly with Mandy, we have this sequence 1, 2, 3, 2, 1. That might not be very likely, but that doesn't mean it wasn't randomly selected. So one of the challenges of being a human being is that we have difficulty truly being random because we like to avoid patterns when we pick a list of random numbers. Whereas if we are truly being random, then patterns can emerge or you do get repeats. So because of this, if we're going to find, if we're going to find a random sample, we have to use some form of random generalization. So I have just a little comment here, a little history on randomness. This is actually like a big thing in stats, is trying to find a way to select random stuff. And actually, we haven't found the best way yet. So even computers have difficulty being truly random. So when I was in school, what we used random number books. So think of an entire book, like hundreds of pages, and every page essentially looks like this. You've got a bunch of just numbers listed there. So the first such book was created by Leonard Henry Caleb Tinfoot, and what he did was he looked at how big the different parish areas were in England, and he picked the middle numbers of those measurements. So something that would not likely have much pattern to it. He didn't want to pick, the first numbers because that might have some patterns based on population density, but he picked the middle numbers. And you can find more information. You can see in the 40s, it was a really important topic because if you were testing and studying nuclear weapons, you needed to know about random numbers. So there's this really cool article on Wired that you can check out if you're interested in that. But these days, usually what you use is, I usually use Excel, or you could even ask Google to find some random numbers for you when you're doing a study. So let's do an example of how we can use random numbers to find a sample. I'm going to zoom out just a smidge here so we can get the full example on screen. There we go. So in this example, it says the 20 most populous cities in the US as of 2022 are given in this table. And Kevin wants to find an SRS, a simple random sample, of 5 cities from this list. So he uses his calculator and he gets this list of random numbers. Now, what I'm going to be checking from you in class is to see whether or not you can use a list of random numbers to find a random sample. So if I asked everybody to create their own random list of numbers, you would all have different numbers, and I would have no idea if you actually got those numbers randomly and how you got your sample. So all of us will be using the same list of random numbers to find our random sample, just so that we know how to go through that process if we need to. One of the things I'm going to point out here is that Kevin wants us to find a sample of 5 cities, but he selected more than 5 numbers. And the reason you do that if you're looking for a random sample is because sometimes you get duplicates, right? Just like Nina did with all of her 3s. So Kevin is going to generate more than 5 numbers so that we can ensure we have enough to find our random sample. Now, the randomness has already been enacted, I guess, on this list. So you're not just going to colloquially randomly choose these, right? So I'm not going to do a 3, an 11, and a 6. I'm going to start with the very first number and go in order because that order has randomly been selected by Kevin's calculator. So the very first number on the list is 1. So we're going to pick New York. Then the next number on the list is 10. So 10 is Austin, Texas. And we're going to continue in this way to find our sample. So the next number is 11, and that is Jacksonville. Then we have number 8, which is San Diego. And then the next number is 11. Aha, I've already crossed 11 off. So because we want to have 5 different cities, I'm just going to move on to the next number. So the next number is 3, and so we get Chicago. So that's why Kevin selected more than 5 numbers. We did end up with a duplicate number. So we just skip the copy and move on to the next number. And it doesn't matter that these numbers weren't used in the end. They were just extra in case we needed them. Okay, now one of the downsides to a random sample is that you can get unintended patterns happening. So for example, if I did a truly random sample, I could get all 3s, or I could get all 1s and 3s. And so I would be missing out on even numbers. I'd be missing out on 2s. So there are a couple of different ways that we can refine this simple random sample to make it a little bit more representative of our group, or to make it a little bit easier for us to find our sample. So let's look at those two types of samples now. Okay, so this first special type of random sample is called a stratified sample. So in a stratified sample, what you're going to do is you first group all of the elements of your population by similarities, and then you pull a random sample from each of those groups. So I'm going to highlight this phrase, a couple things here. I'm going to highlight that you group members of your population. So this type of sampling involves grouping, and you find an SRS from each group. So that phrase, from each, is going to be important. So I found this sample kind of difficult to wrap my head around as a student until I kind of visualized it. That helped me a little bit better. So that's what we're going to do. We're going to visualize this, and then we'll see how they applied this to that paint company example. So I've got a population of shapes here. And what I'm going to do is I'm going to first group them by type. So I'm going to group all the triangles together, all the circles get grouped together, and then all the squares. So those are my groups. Then I want to find an SRS from each group. So I'm going to think of each of these groups like its own little mini population. So I'm going to number all the triangles. And it says we're going to find an SRS of 2 shapes for this visualization. So I'm going to find a random sample just of my triangles. Now, I have a die here, but it's got 6 sides. So if I roll a 5 or a 6, I'm going to ignore it. But let's randomly select those 2 triangles. We got a 3. That'll be the first triangle we pick. And off screen was the 4. All right. And now I'm going to do that with the circles. So I'm going to number the circles 1 through, it looks like 6 in this case. It doesn't matter how you number them. So I'm going to go across 1, 2, 3, 4, 5, and 6. And let's pick 2 circles. So we've got a 3 again. I rolled a 3 off screen and a 1. So circle 3 and circle 1 would be selected. Let me highlight my circles that I'm selecting here. So we got this circle and the circle. And we picked this triangle and this triangle. All right. And then for the squares, we're going to number all the squares. So I have 1, 2, 3, 4, 5, and 6. Again, it doesn't matter how you number the squares, just 1 through 6. I got a 5, so I'm going to do 5. And 3. This die seems biased towards 3, doesn't it? But that's because I'm a human and patterns seem suspicious to me. But in true randomness, patterns can happen. All right, so those were the squares that we ended up selecting. So there you go. That's what a stratified sample looks like. You treat each of the groups like its own little mini population, and you find an SRS from each of those groups. So in the example with the paint company, it says the paint company separates the households in Boston by income tax bracket. They then take an SRS of 20 households from each tax bracket and record those house colors. They then repeat this process for the households in San Diego. So they separate the households, so they're grouping. They separate by income tax bracket. That means these are the groups. So in a stratified sample, you group members. So we have groups going on here. And then they took an SRS from each group. So this phrase from each is showing up, and that's our clue here for a stratified sample, the from each. So that's what makes this different from a simple random sample, is that there's grouping going on. In a simple random sample, you don't do that kind of grouping. Now let's look at another type of sampling that involves groups, but in a different way. So this is called a cluster sample. Now, in the stratified sample, things were grouped by similarities. In a cluster sample, typically the population already has some pre-existing groups. So maybe these groups might be zip codes, or the groups might be like streets of a city, something like that. So in this case, we have all of our shapes already grouped up into pairs. Then what you do is instead of selecting, a random shape from each of those groups, you're going to just select groups themselves and look at every shape within that group. So important things here is we've got grouping or clusters happening. And then we're finding an SRS of groups. So in stratified, we found SRS from each. In cluster, we find SRS of. Okay, so that's going to be important language that will help us identify what type of sample we're looking at. So let's go ahead and find a cluster sample of these 6 shapes. So let's see. First, I'm going to number each of these groups. So instead of numbering the individual shapes, I number the cluster that they belong to. And again, it doesn't matter how I number these. Just make sure each group gets a number. Now, I'm going to find an SRS of groups. Now, this time my die is not going to work, so I've got to find a different method. I'm just going to ask Google. So let me pause the video and ask Google for some random numbers, and I'll be right back. All right, I have returned, and the random numbers that I was given were 2, 5, and 3. So those are the 3 I'm going to use. So what I'm going to do is I'm going to take the entire group 2 and survey everybody in that group. So I'm going to survey that particular triangle and that particular circle. Then I'm going to go to group 5 and survey everybody in that group. So I survey that circle and that square. And then group 3. And group 3 had 2 triangles. So there you go. That's how I would find my cluster sample. Now, in this case, I noticed something a little, I guess not alarming, but a little alarming here, is if I look at my sample, I've got a lot of triangles being represented here. Only 2 circles and 1 square. Whereas in my population, I have 6 squares and 6 circles, but only 4 triangles. So I've got 75% of those triangles in my sample. That seems pretty heavily represented. So if the shapes didn't have anything to do with, what it is I'm interested in, then this doesn't really matter. But if the shape does have an impact on what it is I'm studying, stratified would have been a better way to go. All right, so let's look at the example with this paint company. So it says the paint company takes an SRS of 15 residential streets in Boston and records the paint color of every house on the selected streets. Then they repeat this process for the households in San Diego. So I'm noticing here's our SRS of 15 residential streets. Now this example is a little bit tricky because it doesn't explicitly tell us that they were grouped. So for this example, I need to know that the paint company is caring about the houses. So the individuals are the houses, but they were grouped by street. So there is grouping happening in this example, but it's a little bit more subtle. I can kind of see that because they're recording the color of every house. So the individuals they're gathering information about are the houses, and those houses are grouped on the streets. And they took an SRS of the groups. So here's our SRS of groups. So let's do kind of a summary of some different ways to distinguish between the various samples we looked at, and then we'll wrap up this video. Okay, so, oh, excuse me. So sometimes it can be kind of tough to tell which sampling type you're looking at in a particular example. So here are some strategies that I use to help me make that identification. So first, let's talk about some of those non-random samples that we looked at in the previous video. So two of the sampling types we looked at were a sample of convenience and a voluntary response sample. The big difference between those two is whether or not participants choose to participate. So if you see things like an online poll or people calling in to a radio station or like a news program or something, that means that it's going to be a voluntary response. Sample. Now, one of the reasons I think that it's difficult to distinguish between these two is because a voluntary response sample is a type of sample of convenience. It's easy and convenient for me to post an online poll. I don't have to do a lot of work for that. However, in that situation, I am not choosing the participants, so I can be more specific with my identification and say that it is voluntary response. If the participant didn't choose to participate, so for example, if people are just like walking into a cafeteria or a store, they're just walking in and I'm choosing who to talk to, I've made that choice to talk to that person. Even if they don't answer my questions, I chose them to be interviewed. So that would be a sample of convenience, not a voluntary response. Now, the other type of non-random sample we looked at was a systematic sample. For a systematic sample, you want to look at things like every fifth or every hundredth. And remember, even though this one looks kind of random, it's not random because not everybody has an equal chance of being selected. For the random samples, if you see a phrase like choosing an SRS from each group, then do you remember which type that was? So that's going to be a stratified sample. And if you see the phrase selected an SRS of groups, then that means it's going to be the cluster sample. And as a student, these were the two that I had the hardest time trying to decide between. And lastly, if there is randomization but not grouping, then that means it's an SRS. All right, so that's going to wrap up this video on the different types of samples. In the next video, we're going to talk about how you identify between information that came from a sample versus information that came from a population. So I'm looking forward to seeing you then. In the meantime, have a wonderful day.